Hello everyone, thanks for watching this video. So in this video, today we are going to understand how to find the middle element of a odd singly linked list. Okay, so our task is to find the middle element of odd singly linked list. So now question is that what do you mean by odd singly linked list? So it's just the even and odd concept. Okay, if you see this diagram, you have total 5 node. Okay, so in that 5 node we can easily identify that third number of node is the middle index. Okay, and where we have value placed as a 30. Okay, so we can easily say that 30 is the middle element of the given singly linked list. Okay, in the same way we can also identify the middle element of the singly linked list which have length as a 7, 9, 11. So like that we can easily categorize that this singly linked list is a odd singly linked list. Okay, so this program is mainly focusing on the odd singly linked list. Next program we will be focusing on the even singly linked list, and the next program we will be going to write a consolidate logic or generic logic to find the middle element of any singly linked list. Okay, it should be either even or odd. Okay, but for now our current goal is to find the middle element of odd singly linked list. Okay, let's begin then. So as we already understood that our target is to finding the middle element. Okay, so in order to find the middle element, first task that we are going to perform is create the singly linked list. Okay, second task that we are going to perform is to load the data into singly linked list. Third task that we are going to do is link the node. Okay, and fourth task that we are going to do is, after linking the node, we are going to display the singly linked list. Just to make sure that we created the singly linked list correctly, we loaded the data as per the input diagram, and we did the link between two nodes correctly. Okay, so we did this one. And then fifth task is to find the middle element. Okay, but before that we also have to understand that the given singly linked list is odd or even. So for that we are mainly focusing on the odd singly linked list. Okay, so here probably we can find that identify the singly linked list is odd or not. Identify the singly linked list. Okay, it is fine. That could be your fifth task, and this one would be the sixth task. So we are done with the basic structure of our coding. Okay, now let's begin towards creating the singly linked list. The reason is this is your first task and we know how to create the singly linked list. For better understanding, you can watch program number 1, program number 2 from the same playlist. Okay, so we know how to create the singly linked list. So it will be private static class node. Okay, we can say anything. So here I am going to define the two private data member. Okay, first one is the data and second one is the reference of the next node. Since this singly linked list I am going to create for the integer type, so I can write here as a integer data type. Okay, we can say int data. Okay, and the second one is that reference of the next node. Okay, node. So in that list node reference type, we can have reference name as a next. Okay, so we are done with the half part towards creating the singly linked list. We created the class. Okay, we defined two data member. Now our task is to initialize this one, and we know how to initialize. We are going to initialize these two member using constructor. So let's have public constructor, this one, where we are receiving data as a argument. Okay, so in that, which is again as a integer type, and we know how to initialize this dot data equal to data, this dot next equal to null. The reason is by default the reference of the next node is null only. That's why we are defining as a null. So we are done with the first task. Okay, now second task is to load. To load the data, we are going to have a main program ready here, main method ready here. In that main method, we are going to do the all other remaining. And the second task is to load the data into the singly linked list. And to load the data, we know how to load the data. We are going to create the instance. So we know the first node is also called as a head. So that's why head equal to new list node. Okay. So here we are going to pass data as per this diagram only. So that we can understand clearly. So 10, 20, 30, 40, 50. Okay, so 10. Okay, this guy want 20, 30 and 40. That much only, right? 50 also. Okay, 50. Okay, so the first node is also called head, so that is fine, change is not required. Second node we can say second, third, fourth. So we created total 5 nodes. First node is called 10, where I have placed the value as a 10. Second node, where I have placed as a value as a 20. This is the third node, where I have placed value as a 30. This is the fourth node, where value is 40, whereas fifth node value is 50, as per this diagram. Okay, so which is correct now. So we are done with the second task. Third task is to link the node, and we know how to link. Okay, so here head dot next is the reference of the next node. Okay, equal to second. Okay, and second dot next equal to third dot next equal to fourth dot next equal to fifth. Okay, and fifth is the last node, so no changes required, no connection required. So head I am connecting with the second node. Head actually the first node, so first node I am connecting with the second node I am connecting with the third node I am connecting with the fourth, and fourth node I am connecting with the fifth, and we have total 5 nodes. So we are good till now. Okay, so we are also done with our third task. Now fourth task is to display the element of the singly linked list, and for that we are going to write a display method here. Okay, so in that display, as per earlier program, we are going to pass only head as an argument, since we are going to traverse from head to tail. Tail means last element. Okay, and accordingly we are going to create the data here. Okay, good. So as we know, we are receiving user input here, which is head. So as soon as we receive the user input, our task is to create a local variable just to secure the user input. So the local variable name is current. Okay, good. Now to display, we are going to traverse, and to traverse we should be having one while loop which will help you to traverse from first node to last node. First node to last node. First node, we know this is the first node. Okay, now how we are going to last node, that we already know that as soon as we reach the null, we will be understanding that okay, we reach the last node, so that we need not to traverse from this node to the next node. So that's why we are checking here, we are telling him the node should not equal to null. You just have to traverse, or you just have to run until unless this occurrence should not reach the null. Okay, then we will be understanding that okay, we got the last element. Okay, good. Now we should be having SOP. In that SOP, current dot data. So basically we are only interested to get the data only. That is fine, we got the data. And for each and every data, for data means node of the linked list. Okay, so this is the one data, and again it will be printing the second data. That's why I am giving this separator here. I want everything to be in single line, so no new line. Okay, so this is for the I am able to print the data. Okay, now question is, I should be going from one node to another node. So how should I go? So for that we know we have the next method, next reference of the next node, so that we can traverse. So current equal to current dot next. So this will help you to do the movement from one node to another node. So we are good. So as soon as we come out of this loop, means we reach the null. Okay, so just for our namesake, we also print the reference of the last node, just to for our understanding that okay, we reach the last node. So we are good now. So we are almost done with the display. Now if we run this program, we can able to get the output whatever data we loaded. So we loaded 10, 20, 30, 40, 50, and we did the linking. So our expected output should be 10, 20, 30 and 40, 50. Okay, if you see 10, 20, 30, 40, 50. So we are good till here also, no problem. Okay, now our task is to, fifth task is to identify the singly linked list is odd or not. To identify the singly linked list is odd or not, first task is that we have to find the length. Okay, that probably we can say here. Fifth is find the length of singly linked list. Okay, then probably we can say this one as a 6 and this one as a 7. Okay, good. So to find the length, again we are going to write the logic to find the length only. Okay, so here we are going to do the rename as a length. Okay, and same we are going to pass head as a argument. Accordingly we are going to create it. So we created one API called length, where we are receiving head as a argument, and we know as soon as we receive this argument we have to secure, so that we are creating the one local variable called current. okay, where we have head reference. Good. Now to find the length, as per previous program we already know how to find the length, but anyhow we are going to understand same thing here again, okay. So for that we will be having one while loop, same as display method, where we are checking as a I should move till not null, since null means we are reaching to the last element, okay. And here our task is need not to print anything, so I am not going to give any SOP here, okay. Now I am going to say I am just doing the movement from one node to another node, okay. So to movement current equal to current dot next, this will help you to do the movement from one node to another node. So to capture the movement we should be having one counter variable, means how many times this movement will happen, that many times this counter will increase, and at the end counter value will becomes the our length, so that we can have one local variable called counter equal to 0, okay. So as soon as we are coming out of this while loop, the counter have the sufficient number of movement that we did here, so all number of movement captured into the counter variable, so this is only going to give us the length, okay. So we can return this counter here. So now instead of void we can say this is the integer type, since length is integer, and we are going to return, and counter we are returning. So we are good now. So finally we are able to get the length also, okay. Now this length is returning integer type, so we can easily save the data into the length variable, which is again as a integer type, okay. Now we can have one SOP here saying length of singly linked list is, okay. What is, okay. Now if you run as a Java application, we will be getting length also. So length is 5, 1 2 3 4 5. Null is the reference of the last node, so no need to count. So our linked list is still here to here only, and length is 5, which is perfectly fine. Good. Now our task is to identify the singly linked list is odd or not. The simple, this is a this is mathematics logic only to identify how we are going to identify this is the odd or not, okay. So for that we can say if length m%2 equal to 0 means no remainder, then we can say that linked list is even, or we can say that else linked list is odd, okay. Now run this program just to make sure that we gave the correct condition. This linked list is odd, and which is actually odd, since length of singly linked list is 5 and 5 is the odd number. So we are good now, okay. So whatever we are going to write the logic here only, okay. Good. Now our next task is to, here our next task is, that is 6.1, is to get the middle index, okay. Now how we are going to get the middle index, okay. So for that we can say that and have one local variable called middle index, middle index equal to length, okay, length divided by 2 plus 1. Okay, so this will give you the middle index. Now if you print the log here, what is middle index? Right click, run as Java application. If you see what is middle index, middle index is not coming because, okay, sorry, we are working on odd. Okay, so let's cut this area. We are not working any in even area, sorry. Okay, now right click, run as Java application. If you see what is the middle index is 3, means 1 2 3 4 5, so 3 is the middle index. That also we are able to find. So we are good now. We can delete this line here. Okay, this is for even, and our main, this program is only considering for odd linked list. Even we will understand into the next program. Okay, so for that, now we understood that how to get the middle index. Okay, now question is that how, now our main program is that how to get the middle element. We found the middle index, we haven't found the middle element. Okay, so for that, find the middle element here. So again we are going to write the logic to get the element. Get middle element. Now here what are the things that we are going to pass? So this is the question. So first thing that we are going to pass, since we want the middle element, so we have to traverse. Okay, so we need to have a head, first argument as a head. Okay, and second argument I just want the middle index. Okay, this index value, with the help of this index value, I will be getting the element from the linked list. So let's have this into the else condition only. Okay, fine. Why this compilation error? Okay, let's have this one here. This is giving you the, okay, so we can do one thing, we can initialize this one somewhere here globally equal to 0. Okay, and here you can delete this one int. Okay, good. So now what the problem? We are going to create the method. Fine, so we created method here. Good. Now we receive two things from user. First thing is the head, okay, and second thing is the index, from where we are going to pick the element. Okay, so we receive two things from user and we are going to secure both. So the local variable name would be current equal to head. Okay, and middle index means we can say the mid index. Fine, so we got the two things. Now our responsibility is to pick. Question is that how we are going to pick the element. See, our logic is very simple. We have the index value and we know this index value only our element is available. Okay, So we will be start traversing from here to till mid index, okay, and as soon as we reach the mid index we will just get the value, okay. Now question is, while traversing, how we are got to know that we reach the mid index? So for that we are going to have one local variable called counter that will help you to do counter equal to 0. Now how we are going to use this counter, that is matter. Now question is that we are receiving head here, okay, and we are still not sure that whether it is really head or not, means this could be null also, right? If this is the null, then we can say that this linked list doesn't have any length, means 0 length, right? So we can have one validation here. If head, okay, equal to null, then we can say that counter equal to 0, means no length, okay. Else one thing is very sure that this wouldn't be 0, this should be either 1 or more than 1, means if this is not the null, means it has some node, but we are really not sure that how many node it has, but what we are sure, it has at least one node. That's why we are saying that counter equal to 1. This is the number of node, okay, that I am trying to match with the middle index. That's why we declared here, okay. This logic you have to understand very clearly, okay. We check the head, this is the null, then we can easily say that, okay, the singly linked list that is given by user is null, means length is 0, means actually this is not the singly linked list, means singly linked list has at least one node, then we can say, okay, this is the singly linked list. Since it is null, so we can say length is 0. Length is 0 means counter equal to 0. Now we are coming to the else part, means head is not null. Head is not null. So in that condition, we can say that, okay, if head is not null, then the length of singly linked list is must be a 1. Must be a 1, but it would be more than 1 also. But guarantee is that 1 is pakka, okay. So following with that only, we are going to have one while loop, okay, which will help you to do the scanning. So in that scan, we are saying we are moving till last node. How we are going to make sure that we reach the last node? Since we know that last node will be null only, so we are checking till not null, okay. And here we are increasing the counter plus plus, okay. Now we are doing the movement, current equal to current dot next, okay. This is doing the movement from one node to another node. So as soon you can have this one, okay, as soon as this movement happen, this counter will be getting increased, okay. Now this, with the help of this while loop, I am traversing from one node to another node. I am traversing with the help of this line, and how many times this line will execute, that times counter variable will increase. So at one moment the counter variable also reach the middle element. First it would go the first position, then it will go second position, third position, likewise it will go till end of the singly linked list. But we don't want to go the till end of the singly linked list, we want to go only the middle index of the singly linked list. So this will go also there. So we can say that if the counter, okay, which is capturing the moment, equal to middle middle index. Okay, then please get me the value, right? Then please get me the value. The value is middle element. What is the middle element? Current dot data. This will give you the value, and this value available where? Middle index. Middle element this, and middle index is this one, middle index. If you print this one, if you see here, what I am doing is I am just got the middle element, okay, this one, and middle index this one. So right click, run as Java application. If you see 10, 20, 30, 40, 50 is your singly linked list, and length is 5, which is also correct, and linked list is odd, which is also correct, and middle element is 30, which is available in index 3, which is also correct. Okay, so let me summarize you the question again. So our task is to find the middle element of our singly linked list. So in order to find the middle element, we have to create the singly linked list, and we know how to create. We have the private static class where we declare two private member, data and the reference of the next node. We initialize both of them using constructor, and by default the reference of the next node is null. So we are done with the first task. Okay, second task is to load the data. So we created load the data 10, 20, 30, 40, 50 as a first, second, third, fourth and fifth node. First node is also called as a head, so we rename the variable name as a head for our reference. Third task is to do the linking between each and every node, that we did head.next equal to second. So first node got connected with second, second got connected with third, third got connected with fourth, and fourth got connected with fifth. So we did the interconnection. After doing the interconnection, we are just doing the display just to make sure that we created, loaded and interconnection between each and every node is correctly. So that we are verifying through the display method. Now after display method, we are going to get the length of the singly linked list. So in order to get the length, we just have created one counter variable that got increase of each and every moment. Okay, so that will, at the end it is returning the length of the singly linked list. By getting this length, I am just identifying that this length is even or odd. So if it is even, I need not to do anything, since this program is mainly focused on odd. So all the logic will go here in else condition, making sure that our singly linked list is odd. So to find the middle index, we divided length by 2 plus 1. This will give you the middle index. So we got the middle index for the odd singly linked list. Okay, and that middle index I am passing here along with the head value, and here I am just trying to get the middle element. In order to get the middle element, I am just traversing from one node to another node. Okay, so while traversing, I am just increasing the counter variable. Okay, and this counter variable, as soon as reaching the middle index variable, actually counter is nothing but this is also indexing only. Okay, as soon as it is reaching the index value, I am just printing the data, okay, and the index. Another logic is that how this counter variable getting increased. So if the head is null, means that singly linked list is blank, means counter is 0, means there is no movement required. If counter is not 0, then we can say counter must be 1, means singly linked list has minimum one node. So it will be 1, but max note that we are checking through this one. So that's why initialization of counter variable is 1. Okay, and with respect to that I am just started iterating and I got the expected output here, which is singly linked list, length is 5, which is odd, middle element is 30, which is available at index 3. Okay, yeah, thanks for watching this video.